Today we speak about the SRE for AI. So vice versa. Yeah, and AIRE, AI reliability engineering. Because of unreliable AI is worse than no AI at all. And just to be the long story short, I would like to mix two paradigms. One of them is the upcoming wave of the AI, and this is the really highly recommended things from Mustafa Salman about this huge wave that we are expecting. But you can see that he says that soon we will live surrounding by AIs, but we are not prepared. And this is the main point. And the second one is all about the 97 things every SRE should know. This is the collective wisdom from our SRE community about the vision of the SRE. So if you would like to, you can check it. Yeah, I really recommend it. If you try to find the way to start with the SRE and AI, this is the maybe main things. Because of, for the SRE point of view, the curiosity is it means that rather than seeing one of the specific parts of the system, the SRE instead wonder about the whole system and especially under the hood. And I would like to say that we as a SRE, how many SRE have? Yeah, great. So we now in a unique position because nobody knows what is the AI, how it works under the hood and whatever. And we all one of the people that's an engineers that's really curious how it works under the hood. Okay. Yeah, and agenda for today. If you are still here, we are starting with the emerging AI challenges. So all about the challenges because of for now, for example, the silent model degradation is a production event for us. So this is the paradigm shift here. Next, we a bit deep dive with the ecosystem. So we're all about the tools. I guess we all very curious with the tool set and whatever. So on. And the third one, it will be some kind of practice, SRE practice applied to AI. So we need to ensure that AI-driven applications remain reliable. And you can see that a lot of new terms for us with this era: inference, evaluation, surf, build, LoRa, and all kind of goof, ONX, and whatever. So a lot of stuff to learn. Some kind of infographics about me. Shortly, I'm originally from Ukraine. And first of all, thanks for who's supporting us. Yeah. Experiencing in telco, so all networking and all this stuff. Have some kind of experience with the mobile network operators, startups, software engineering. Now I'm senior SRE for National IQ and JFK. This is the AI-driven data analytics platform. And actually, funny thing, yesterday, for the first, I had the 2 days off. And first day on SRE conference, HR dropped me a mail that I was promoted to principal and they considering, and next week we're expecting some kind of proposition or something here. And really, you are first with whom I've shared this. So that's why. But still, as a senior engineer, because as a seniors, we actually have a position that we can do a lot of interesting technical side. Because of next, it's more about the meetings. So beyond that, public speaking, and I teach the Kubernetes, GitOps, all the stuff. I'm focusing on the Kubernetes controllers, and I guess soon I have some kind of inner sourcing project, and it's become the open source. AIRE that we are talking about now, we are in initial state of some kind of startup. I call it mocking. So this is the mix of the human intelligence and artificial intelligence for the mock interview preparation, assessment for the SRE, and whatever. Interesting thing that And actually, this is the chance to make it hands-on with all this stuff with the LLM and whatever. And yeah, I lead the YouTube channel and the DevOps podcast. Yeah, free to join me in social. And first, let's define what's the term AI for this topic, because everyone treat AI whatever they want. But now we talk about the inference. So inference, this is when the model utilizes its knowledge to respond to the real world inputs. So this is the real-time thing that's actually the artifact of the model. And first time I heard this quote from Clayton Coleman. It was the KubeCon North America. Tim Hawkins actually from the main stage of the KubeCon, actually on the keynote, we speak about the inference is our new web application. So because of 5 years ago, if you are asked the SRE, what are your job actually? We all about the reliable of our web applications. But now we have the shift and so many new challenges become. By the way, next week KubeCon, who will attend? Yeah, good. Yeah, and let's start with the key aspects of the inference workloads. Because for me as a SRE, the inference workloads, this is the artifact I care about. And all think about the AI, it's focusing on the workloads. I would like to maybe, recommend. Who knows this guy on the right screen? Yeah, thanks for him. I start career because of Patrick. Yeah. So enterprise Gen AI delivery patterns. He's gang actually focusing on the enterprise side of this. For my side, for example, in the Moki, we're focusing on the self-hosting models and whatever. That's why this is the opportunity to play it hard. So what we have with the key aspects, we have real-time and batch processing. So because of inference for the LLM Gen AI, it's real time. So it's for example, so the online inference, this is the prediction, this is the chatbots and even self-cars, so self-driving cars. For the batch processing, it's offline. It's more about the log analysis, image classification or trend forecasting and whatever. But the thing is that we have in real time, we really have the new SLA, SLO and whatever with the latency. Next, resource requirements. Because of, unlike the training, in case we spoke about the ML, the real-time inference required lower computation power, but same latency and high availability for it. What else? For CPU, GPU, TPU, and accelerators. For sure, we will talk in a minute. The resources in our age, actually, this is the really point. What next? Deployment strategy. So we can start on-prems, we can start managed cloud solutions, whatever. So it can be Hugging Face, Vertex AI, Together AI, maybe, or even self-hosting if you have special devices and whatever. Optimization. Who knows about LoRa? Why we use LoRa? Okay, low rank, yeah. Low rank adapters, and this is the point when we jump to the AI gateways and whatever. Next, monitoring observability. For sure, there is AI-specific tracing tools, and I would like to show you in the 5 minutes maybe the open inference framework to instrument your LLM or AI application to get the metrics, because we need something to build our SRE stuff on it. Scaling strategies. After scaling and load balancing. And this is the really problem for now, because the Kubernetes, it's most about the stateless application and not about the distributed application. So no distributed jobs and whatever. So that's why this is the point we need to focus on. What's next? Security. For sure, security, because of a lot of stuff related to the all kind of authorization, data poisoning, tokens, and, for example, multi-agent applications. So there is a lot of API calls outside of our perimeter and whatever, and they are unpredictable. And what I would like to summarize the AI reliability require with the different approach. So because of AI is unpredictable, unlike the web application. So because of it's some kind of the same input returns every time the different outputs. A model can be 100% available, but produce incorrect and unpredictable results. Agents we already speak about. So because of unpredictable execution paths, for example, the MCP or ACP, the new hype from the IBM and whatever, a lot of multi-steps, multi-calls, outside perimeter, inside perimeter, and whatever, we need to control this. Latency and performance bottlenecks. For sure, there is API calls to the third party. That's why we really cannot predict these latencies, but we need to define the SLA. And for example, as I mentioned on the beginning, the silent file failures. So this is some kind of model decay. So that's why the different from the traditional software. In case of web application is down, we immediately have the crash log or errors and whatever, but AI model can degrade silently. And this is the problem because of we need some kind of new approach to register this inaccurate, inconsistent outputs, bias, and whatever. So we have plenty new challenges. And this is some kind of infographic of all kind of challenges we have. So first one is all about the process. So should we build by use open source and whatever? How to deploy, how to serving this model? What about the latency? What about the performance? What is the FinOps? Because of, we care about some kind of cost in our infrastructure, but now we also need to cost and resource management included in our dailies. Next, legal and data protection, because of data poisoning and the legal things and all kind of pacts on Europe, USA, and whatever. We need to be sure that we understand what is this. And security and data poisoning when we use any data for now. So the second part on the right side, this is all about the new features and tools we are using now to process and serving the LLM. So we have all kind of runtime, distribution, FinOps, performance, and this evaluation, and LangChain, and transformer. So we have a lot of new things. And the technical side, because of we have changed workload. Now our container is about minimum 5 gigas. The maximum it can be 100 gigas. We needed training in case the researcher, the red sheet is a researcher and the blue one is the SRE, I guess. He must struggle, because of we need to serve, we need to store, we need a lot of things, and especially in case of we have the huge size of workload, the struggling with the networking. We need to care about the latency and the same time about the data transfer inside of our networks. And next, metrics, security, and monitoring, tuning, and optimization, because of this is not just the researcher metrics for today. This is our metrics because of this is our SLA. So the new challenges for SRE, observability gaps, for sure, because of before CPU, memory, latency may be something else, but no AI specific, like a drift or confidence score and whatever in our perimeter. I don't know. So serving challenges. This is the specialized traffic routing, rate limiting, and all kind of security and formats. That's why, for now, AI gateways appear on the scene. Bloomberg, Solar IO, or even Kubernetes Gateway AI extension, inference extension. What next? Inference workload scaling. Because of Kubernetes is not fully supporting actually, and originally, as I mentioned before, they designed it for the stateless more, because in case of stateful, we already have some kind of problem. But in case of the LLMs, all kind of generative, we have more things to care about. And for sure, the security compliance risk because of data leaks and authorized and these jailbreaks just in real time. Okay, so this is our new challenges, and what's the modern ecosystem for the inference workloads for today. This is my point. I like this slide because of all this stuff is a mess because of this is our ecosystem for today. A lot of stuff you need to every day, some kind of startup, some kind of new technology and whatever. And you as SRE engineers should be make the decision to what we are bringing on a production, what we may bring in your perimeter and whatever. But anyway, here all the stuff I'm really hands-on with each one. So starting from the LangChain, Open Inference, VLLM, after GPT or Llama, and all the stuff. AIRE, for example, Array core. Array is distributed computing and whatever. So for the Kubernetes perspective, I'm really recommended the special interesting group that's already worked on for the Kubernetes ecosystem. This is the serving, this is the device management, gateway API inference extension, all kind of AI gateways, and observability and evaluation. So this is the working group on the Kubernetes focusing for optimizing the serving. So this is all interfaces, all routing, networking, optimization of the NT tables, IPOS, and whatever. Device management is all about dynamic resource allocation, because this is the very hot topic for today. IP inference, gateway API, you know that we are switching from the ingresses to the gateway API, and now we also have this extension for inference especially. And I will show you in a moment the all kind of schema. And what else? The AI gateways is already, as I mentioned, Bloomberg, Sol.io, and whatever it's worth to learn about. And for sure, there is observability and evaluation. And observability not on the high level, starting from the model, from the application itself. By the way, this week, Tuesday, we have so amazing meetup in the Google Cloud with the AIRE itself. They presenting this, they already all well known, but they presenting more feature with the building better AI agents itself. So evaluation, the agents itself, because of before they focusing only on inference, LLMs, models, and ML. Now it's all about the models, and recommended you if you have a chance to double check it in the AIRE official site. What's next? How we can apply the practice in all this stuff? So first, SLA, SLO, SLI. Yeah, we need to define the specific metrics relevant to the AI. Monitoring and observability. AI-specific tracing tools for the LangChain and whatever. Yes, in case we speak about the Open Inference framework, it's all about gather the metrics and send it into OpenTelemetry. Who's used OpenTelemetry on your applications? Perimeter, yeah, we're all in the same page. Yeah. Next, incident response. Because for now, we need the clear procedure for the AI-specific issues, like model degradation. Because before, we just know it's down, there is lack of CPU, memory resources, and whatever, but this nuance of the degradation. So what else? Security and ethical consideration, because we need some kind of protecting level for the real-time inference to avoid all kind of this, for example, adversarial attack and data breaches and jailbreaks and whatever. Capacity planning. Before, with our infrastructure, we have some kind of microservices, and it was limits request on the Kubernetes the best thing we can. For now, this is the special devices, CPU, TPU, distribution training, and all the stuff with the really large machines, actually, because of node pools for today, this ten of thousand each one. And so this is some kind of summary. And this is, I call it mental map of modern SRE because especially for the AI. You can see there is a blocks from the top to bottom. AI gateways. We should understand the principle of AI gateways, what and how to route traffic based on model or hosted or on sourcing and out of our perimeter. Next, there is some kind of gateways and all kind of model mesh, model rollouts, and all this stuff. On the middle, we have some kind of model serving because of, for example, my favorite is the serving models with the Kubernetes controllers. And it's worth to look on with AI. This is the first try to use the controllers to bring the AI model from the OCI, Open Container Initiative, storage to your cluster and start the web front end, back end for the model and all instrumentation around on it with the controllers itself. So it's my favorite. That's why I'm talking about. And also on the basement, we need the all kind of instrumentation for tracing and evaluation for the model on the schema. So this is some kind of infographic, mental map, or whatever to serve your AI application based on any kind of the model. And next, this is the main groups of tasks: security and control plus observability, AI gateways group, routing, balancing all gateways, orchestrate. It can be Kubernetes in most of the case. And today, the last one, the latest update, it's 65,000 nodes in the Kubernetes. And in case you found the podcast, Google podcast about the Kubernetes, they invite all of these guys that they explain why we need so huge clusters. It's all about AI. And model evaluation and tracing with the Open Inference protocol. This is the tracing, how the loops tracing. I have demo, but I guess I just, 3 minutes? Maybe, okay, I will show you the demo with all the stuff, how to trace the length chain. So and this is how we can gather the metrics to make the further decision with especially for the SRE, SLIs and whatever. So this is the sample document that we have new commitment with the uptime, with the inference latency, fraud detection, for example, and incident response. And we can start learning the new paradigm for the SRE. And back to these two books. And Bjorn from Grafana Labs, on the last article of the 97 things every SRE should know, he mentioned that now we on the third age of SRE. First age, it was the Google feature. Second age, it was some kind of our implementation SRE on our perimeter because we are not a Google. That's why we struggle with all these things. But he said the third stage or third age of SRE becomes when everyone, developers, engineer or whatever, they start learning or do or implement something with the SRE in mind. I'm okay with this, but from my point of view, the third age of SRE, especially AI reliability engineering. That's why we are here. And maybe the final, I guess this is the right time to start to speak about the AI reliability. And my dream maybe is to have some kind of roundtable of SRE, because you have experience, you can share the experience and whatever, to build or to found some kind of framework, what we should do for the startups, for the enterprise, for self-hosting model, for security things and whatever. So it's some kind of the, let's say, framework. I have this very interesting discussion with the Patrick Debois. We have a call with him about the DevOps side and the SRE side. It's all about the AI. And he said that for now, it's too early for the frameworks because of a lot of new stuff. That's why we need to start this open discussion. And that's why, yeah, we are here, and I really appreciate for your time, for your attention, for your experience that we can bring to the AI reliability engineering. Yeah.